Now, one last thing we need to talk about before we actually start doing calculations involving strong acids and bases. That's this category down here called nothing. When I said that this was the category of nothing, this was the category of stuff that did not behave at all like an acid or base. You throw it into water and you check the pH, 7. Remember, for something to be an acid or a base, it's got to upset the water equilibrium of having equal amounts of protons and hydroxides. Right now, water makes protons and hydroxides. If I throw something in it and I still have the same H plus and OH minus, then they're both still 10 to the minus 7 molar approximately at room temperature. pH is still 7. I'm not doing an acid-base problem. Are there things I can throw in that are like that? Yeah, we know that. If I throw some sodium chloride into water and it dissociates and makes Na plus and Cl minus, and I measure the pH, it's still 7. So evidently there are compounds that are not acidic. They're not basic. They don't do anything in terms of acid-base chemistry. I refer to the ions that do nothing in terms of acid-base chemistry as the spectator ions. If I give you a problem to work, and you've got this big old problem, and it's an acid-base problem, and there's all this stuff sitting in there in the way of chemical compounds. Here's a chemical compound. Here's a chemical compound. Here's a chemical compound. Here's a chemical compound. The first thing you have to do when you look at that problem is say, what stuff is my strong acids? What stuff is my strong bases? What stuff is my weak acids? What stuff is my weak bases? And what stuff doesn't matter at all? What stuff is a spectator? If you can get rid of your spectators, you take a problem that is complicated and you make it easy. Which means that in addition to knowing what's strong and what's weak, you have to identify that stuff which does nothing at all. And you do that because if you've got something like HCl, and you've got something like NaOH, and you've got something like NaCOOH, and you've got something like KBr, and they've all been thrown into water, and you need to talk about the pH of that solution, don't you think it would be a great thing if you knew the spectator so that you could say, chloride is a spectator. It does nothing. Sodium ion is a spectator. It does nothing. Sodium ion is a spectator. It does nothing. Potassium ion is a spectator. It does nothing. Bromide ion is a spectator. It does nothing. Everything I crossed out gives you a pH of 7 when you throw it in water. Ignore it. As a result, when you're done, instead of having some incredibly complicated problem with all these ions running around, I'm down to only those things which actually matter. I'm down to protons, hydroxides, and, in this particular case, a weak base. So, that's why spectators matter. And now I'm going to show them to you.